Right. Here we are discussing about the types of chemical equations. Right. What are the types? Right. Before going that, we completed three activities. Right. In that, what we will do? We are representing that reactions, activity 1, activity 2, and activity 3. In that, we are counting the number of atoms present before the change individual atoms before the change and after the change. Right? So observe the following equations and count the number of atoms on reactant side and also on product side. For example, first reaction between calcium oxide and water. So they are what? Reactants. So combining before the change. So they are taken left side to the arrow here. Calcium oxide, quicklime, water, H2O. They are togetherly producing slacker line calcium hydroxide. So this is the equation for the activity 1. Right? Here I need to count the number of atoms before the change and after the change. Individual atoms. What are the atoms present in these? Here, see. Elements I am observing. Calcium is there. Oxygen is there. Hydrogen is there. Oxygen already I taken. So, 3 different atoms there. 3 different atoms there. Are you clear about the 3 different atoms before the change? How do I take in? Are you following? Then see reactant side. Reactant side, okay, calcium is there, oxygen is there, and hydrogen is there. Do you see any new element after the change? Any new element is there after the change? No new element. No new element. So need not to check always. You need not to check always. Just we are generalized. There is no new element produced after the change. In a chemical reaction, only the combination changes. Okay. Then here I need to count them. So for that, I am making a table. Right? For what purpose? Here, atom on reactant side and also on product side, I am checking. Right? So what are the atoms are there? One is calcium, one is oxygen, and the other is hydrogen. So here I am noticing atom name. Then I am checking the count of calcium. What number of atoms are present on reactant side? What number of atoms present on product side? The same element. So here I need a table for 3 different observations: atom, reactant side, product side count. So I will make a table to note down that. So make a table depending on your number of atoms, right? And for heading. So headings, atom or element, then reactant side, and number of atoms on product side. So I made a table. After this, I will notice what actually that atoms present on reactant side. No need to check your product side because the same atoms will be produced, but combination is different, right? So left side, I have calcium, oxygen, here hydrogen and oxygen. So oxygen, the number of times repeated here, 2 times, but we will consider only 1 time, but we will take the counter where they are. So follow me carefully. Here calcium is there, oxygen is there, and hydrogen is there. If it comes number of times, don't write number of times, only 1 time you can consider. So I considered oxygen only 1 time, but it is repeated in 2 different substances, right? 2 times. Only we are written 1 time. So this you have to write. So calcium, oxygen, and hydrogen written. Then counting them on reactant side first. Here, look at formula, calcium oxide, right? In this, are there any numbers, numericals? No number. Calcium oxide is there. There is no subscript or there is no coefficient. So nothing is there. If nothing is there, we will take it as 1 before and in its subscript. So count of calcium is 1 here in the calcium oxide. Does it repeated anywhere on reactant side? No, not repeated. So I will take the count of calcium in the table as 1 here, where it is in the calcium oxide. Then we'll go for oxygen count. So here oxygen present here and also here. How many? Here nothing is there means 1, nothing is there means 1. Then totally 2, 1 plus 1. So number of oxygen atoms on reactant side, left side, they are taken to be 1 plus 1, 2 here. Then hydrogens on reactant side. So here hydrogen only at 1 place, that is here, and it has subscript. So 2, before coefficient nothing is there. So we will take the product of coefficient and subscript. So 1 into 2, that equal to 2. So I will note down that count of hydrogens on reactant side 2. Are you clear how I am written that in the table? Go to quick reaction. If not clear, immediately ask me. If not clear, ask me. Everyone clear? Harshit, is it clear? Harshit, how I am written the count of atoms in the table? Are you clear or not? Right. Here I got the count of individual atoms on reactant side. Then I will go to product side, right hand side. Right. So here right hand side, I have only 1 product. In this, I have calcium atom, only 1, right? Is there any bracket for this? Nothing is there. That also we need to check, right? So nothing is there. Its count is 1 and coefficient is 1. So we'll take the count of calcium on RHS side or product side as 1. Then oxygen, it is enclosed in the bracket. Look at that composition. Oxygen enclosed in the bracket and it has subscript. So this will be distributed to both like this, right? So how many oxygens are there? 2 here. So that I will write the count of oxygen on RHS side. Then hydrogens also 2 here. So I am written. So like this, we will count the number of atoms on LHS side and RHS side. LHS side means left hand side, that is reactant side, left side to the arrow, right side to the arrow, right hand side, that is product side. Everyone clear how I got the number of atoms for the first activity equation? Yes. Go to quick reaction, otherwise I will be in confusion. Are you following me or not? Yes. Okay, so it is about. Then we have second equation. What is that second equation here? Simply, second one is given the reaction. Sorry, second one, third activity is there. Third activity is what? The reaction between the zinc and the hydrochloric acid. The reaction between the zinc and hydrochloric acid, activity number 3, that producing a gas and a liquid solution left in the test tube. So what is that? Zinc chloride and the liberation of gas tested with the burning mastic, observed blue color flame, pop sound, put off. That is hydrogen, right? So this reaction represented as equation. So in this equation, we are counting the individual atoms here. So make a table as you require, number of columns and number of rows. Then headings are same, atom or reactant side and a product side. Then note down individual atoms by observing the equation here. So left side zinc is there. I can write zinc. Left side hydrogen is there. I can write hydrogen. Next Cl, Cl. No atom repeated and no other atoms other than these three. So I'll note down that in the table. Ice, zinc, hydrogen and chlorine. Don't take it's a subscript in the table. Without subscriptions, without coefficients, we can note down that elements in the table. Okay, suppose in this I have hydrogen. I'm not written as H2. That I'm saying. Don't write like this. If you write like this, it is a molecule, not the atom. Right? So don't write the molecules. Follow only atoms. Okay, notice that in the table completed. Then what to do? Counting. So how many zinc atoms are there on reactant side? Anybody help me? Unmute. Unmute. Anybody from you?
One, sir.
One. Okay, keep on unmute. One. Then count hydrogen atoms on left hand side only, reactant side. How many hydrogen atoms? First.
One, sir.
One. How many chlorine atoms on left side?
One, sir.
Okay. Go to product side. How many zinc atoms are there?
One.
Chlorine, hydrogens. Hydrogens.
Two.
Two. And chlorines.
Two, sir.
Two. So are you clear how I am written table for this? Go to quick reaction, counting of individual atoms on reactant side and product side. Yes, clear. Then we will go for third equation that is given in your activity 2. That is the reaction between the sodium sulfate and barium chloride producing sodium barium sulfate and the sodium chloride. So this is the reaction. So I need a table to note down the count of individual atoms. So depending on the individual atoms, you can take number of columns and rows in the table noted, and headings are atom, number of atoms on reactants and right side on product side, right? Then individual atoms. Look at atoms here. Sodium, sulfur, oxygen. 3 there. Barium and chlorine. How many there? Totally 5 there. See, I separated. Counting. 1, 2, 3, 4, 5. So 5 atoms are there. What that? Namely, here sodium, sulfur, oxygen, barium, and chlorine. These are the atoms. Then count them on right hand side and left hand side. First left hand side, right? First left hand side. Rohit, unmute. Help me in counting the atoms. Sodium atoms on left hand side, LHS side. Fast, don't waste the time. Rohit. Vikrant.
Sir.
Stay on mute. Okay. Sodium atoms.
2, sir.
Okay. So, sulfur.
4, sir.
1, sir.
No, only one, because it is not enclosed in the bracket. If it is like this, you can take as 4, right? No bracket. So individually subscription, nothing is there means no subscript. We can take only one, right? Then next oxygens 4. Tell me
4,
barium. Barium.
1, sir.
Chlorines.
2.
2. Then RHS side. Reactants completed. Product side now. Barium, sodium. In the order only I will come. Sodium.
1, sir.
1. Then next sulfur.
1, sir.
Oxygens.
4, sir.
Sodium. Sorry, barium.
1, sir.
And chlorines.
1, sir.
Right. So I am written equations for the 3 activities reactions. Notice any difference in the values before the change and after the change. Here look at. Count before the change and after the change, same. Did you notice that? Count before the change and after the change, same. In this, before the change and after the change, not same. Here also, before the change and after the change, that count not same. Right? Here, no atom created, no atom destroyed. Right? No atom created, no atom destroyed. So here it is simply according to law of conservation of mass. Does the second and third example satisfying the law of conservation of mass? Can anybody? Which is satisfying law of conservation of mass among the 3?
The first one.
Only the first one. What about second and third? Loss. Right? Or count is changed, maybe increased. So what we learned during the chemical reaction? No new element is produced. Here, hydrogen element produced newly. Possibility not there. So here, they are not satisfying the law of conservation of mass. Right? So here in this reaction and in this reaction, right? What we noticed? They are not satisfying the law of conservation of mass. They are against the law of conservation of mass. So here, the equation which is satisfying the law of conservation of mass called as balanced chemical reaction or balanced chemical equation. That which do not satisfy the law of conservation of mass called as unbalanced chemical equation. So first one only called as or represented balanced chemical equation. Remaining 2 are unbalanced chemical equations. So that means we did not consider them as chemical reactions, sir. No, we can consider them chemical reactions, but we have to change that to satisfy the law of conservation of mass by changing the count of atoms, right? But we are not changing the product, we are not changing the reactant. Only the count we are changing. So that changing of count to satisfy the law of conservation of mass called as process of balancing. Are you clear? We are introducing one new topic here based on the law of conservation of mass. So here the equation which is satisfying the law of conservation of mass called as balanced chemical equation, that which do not satisfy the law of conservation of mass, giving you the different count of elements before the change and after the change, they are called as unbalanced chemical equations. So we have to make them as balanced chemical equation. So here I got the types of equations here too. What they are here, the types of equations as balanced chemical equation, and another is unbalanced chemical equations. How I introduced these two types based on the count of elements before the change and after the change, right? So here before the change and after the change, if you find that count is remained same, that equation is called balanced chemical equations, right? Left side and right side, I noticed that change in the atoms same, count is same, then it is called as balanced chemical equation. Example, carbon and oxygen reaction producing carbon dioxide. So count is same, already we observed in the table. Then next, I'm going for another type. If that count is different on product side and the reactant side, or reactant side and product side, LHS, RHS, whatever it may be, you can take, right? That count is not same, right? Count is not same. Then that equation now considered to be unbalanced chemical equation. Unbalanced chemical equation also called as skeletal equation. Remember, one more word is introduced for unbalanced chemical equation called skeletal equation. This balanced chemical equation also called as stoichiometric equation. Stoichiometric equation. Balanced chemical equation, another name, stoichiometric equation. Unbalanced chemical equation, another name, skeletal equation, right? So here simply two different names we got. For balanced chemical equation, stoichiometric equation. For unbalanced chemical equation, skeletal equation. This unbalanced chemical equation also called as primary equation. Also called as primary equation. Remember the different names also. Then here, which you can give example for unbalanced chemical equation, which has different count before and after the change. So zinc is reacting with the chlorine, hydrochloric acid, and giving you zinc chloride among the gas, right? So in this, the count before the change and after the change is different. So here that is called as skeletal equation here, right? So this is about types of chemical equations we are learning in this chapter, right? In your 9th class, you learned about types of chemical reactions. In this, we are learning types of chemical equations. Clear? Are you in confusion? Clear? Or there any confusion? Anyone? Surajita, Tejaswini, Rohit. Yes, no confusion. Right. Thank you. Then we will move to another topic here. What to do if you have an unbalanced chemical equation? We need to balance it. Why we are balancing? Anybody? Why I need to balance? What happens if I left that ice cheese? Answer me. What happens if skeletal equation not balanced? Why do I need to balance it? Harshit, any idea? No? Okay. So here, to satisfy the law of conservation of mass. So here, simply what is actually balancing the equation? Making the number of atoms individually before the change, after the change, equal in count. That process we can call it as balancing of chemical equation. The process of making the number of atoms of different elements equal on both sides of equation. That means on both sides means reactant side, product side, that count must be same according to the law of conservation of mass. If not same, make it balance. That process only balancing, right? So here we are learning a balancing, right? With few steps. What are that steps? We are always following few steps for balancing any chemical equation, right? What they are? First, they may give you reaction without equation. You need to write the equation first using the symbols and formulas. Primary equation we need to write. That is only called a skeletal equation or unbalanced chemical equation. First step is writing the chemical equation. If already chemical equation given, don't go for the first step, already completed, right? Are you following me? Or I am confusing you? Nothing? Yes. So if given already as chemical equation, don't go for the step 1. If reaction given as a statement or word equation, then you need to write chemical equation, skeletal equation. Then counting the individual atoms on reactant side and on product side in a table, as we did in the previous example, right? So count them and note them in the table. On reactant side, product side, individual atom count. Next, selecting the large formula unit. Large formula unit. That means, for example, NaCl is there, Na2CO2 is there, CO3, right? Suppose they are in the same equation, right? Suppose they are in the same equation. Here, count of atoms in the formula unit. Formula unit means that molecular number of atoms constitute a formula called formula unit. In this, one Na atom is there and one chlorine atom is there. So totally 2 atoms is it consisting, right? Okay, I'm going for Na2CO3 now. Here, 2 sodium atoms and 1 carbon atom, then 3 oxygen atoms. Totally it consisting 2, 1, 3 plus 3, 6 atoms. Are you clear? Are you clear about this? What I am written? Counting the atoms in the formula unit. There are maybe different kind, but take the count like this. So which is largest here? Which has more number of atoms in it? That is here Na2CO3. So first I will select that one if they are in the same equation, right? So that is given as third point here, right? Selecting the largest formula unit from the equation for balancing. Okay, I selected largest formula unit. Then what to do? Large numbered atom I need to select. Large numbered atom or highest numbered atom. For example, in the same Na2CO3. Which is large numbered atom here? Anybody? Largest formula unit is this one. In the formula unit, which is large numbered atom?
Oxygen.
Oxygen, right? So first I will try to balance oxygen atoms on LHS side and on RHS side. That is the meaning of fourth point. The next point here, just you are following actually trial and error method, right? For balancing that, you are multiplying the formula unit, not the atom, formula unit by a suitable number, right? Not writing as a subscript. Don't write as subscript. We don't have any right to change the count of atoms by writing as subscript here. For example, Na2CO3 is there, right? That Na2CO3 I am writing by changing the count of oxygens like this. Will you accept? No, doesn't exist. You are unable to change the combination. Just you are able to change the count. So instead of writing here 6, I am multiplying this 3 as a coefficient here 2. So 2, 3 is 6. That will give you again 6 here. But not to write directly, right? So don't write as subscript any number. Write as coefficient only, as multiplier before the formula unit, not before the atom, before the formula unit. Clear? Or any confusion? In the balancing, stepwise I will show you again. But here, got the meaning of fifth point? Got the meaning of fifth point? Yes or no? Use quick reaction. Yes. Right. Then next, okay, oxygen solved. Other atoms may be disturbed. Okay, maybe they are not disturbed, but they may give you different counters. Na is there, carbon is there in the same compound, right? That count may be changes. So that you need to balance stepwise, right? So these are the steps. Let us see here how to balance the chemical equation, right? As an example, I am considering one reaction here. Write the reaction between hydrochloric acid and sodium carbonate, then balance it. Are you given by here equation or reaction? Answer me. Are you given by chemical equation or given by chemical reaction?
Chemical reaction.
Chemical reaction is given. So what is my first step? First step is, I told you steps now previously. See them. Steps. First step is writing the skeletal equation. Right. Second step is counting. Third step is largest. Right. So I will take letters here. First writing skeletal equation. Then next counting. Next large numbered pharma unit. After that highest numbered atom. Then starting balancing one by one. So these are the steps I am following. SCLHB. Okay. So I will move to the another here using that same steps, right? First step is writing the skeletal equation because not given equation here. So I will write the skeletal equation. Okay. So first step is we will write skeletal equation. These steps only following here, right? So first step is writing the equation for the given reaction. That is my step one. Step one, right? Writing the skeletal equation. What is that? HCl reaction with sodium carbonate. So I am using the formulas. Hydrochloric acid, HCl, sodium carbonate is Na2CO3. They togetherly changing towards, so products representing. So acid reaction with the base producing you salt, water, and liberating a gas called carbon dioxide. This is reaction taken from your third lesson, fourth activity, right? So here it is producing you salt, NaCl respectively, then using that here water formed and gas liberated. So these are the products. Okay, first step completed. What is second step? What is second step? I am given code SCLHB. What is C?
Counting the number of atoms.
Right, on LHS side and right hand side RHS side, right? So step 2, counting the atoms, individual atoms on LHS side and on RHS side. So start in the table. So take the headings, atom, reactant side, product side. Then note down the atoms by looking only one side. It may be LHS side or RHS side. Anything you can take, right? So here, what are the atoms present? First, serial wise, I am coming. First, H is there. Okay, note down H in the table. Next, chlorine, Cl is there. Note down. Next, Na. Next, C. Next, O. Are you clear? Are you clear? Are there any confusion? Right, this is. The next, counting. First, LHS side. Hydrogens, only one atom there on LHS side here in HCl, right? Only one. Next, chlorines. How many are there? In HCl only there. There is no repetition of atom here in Na2CO3. So it is only one atom, right? Note down. Okay, next here Na2CO3, just break them. There are no brackets. Remember that. If brackets there, we can distribute that subscript. Okay. Then here count of Na is 2. Count of carbons only 1. Count of oxygens 3. The next, moving right side. Right. In NaCl, Na only at one place. There is no repetition. So count of Na is 1. H and Cl is there. Only once it is observed. So here count of Na 1, Cl is 1. The next hydrogens not repeated. 2 oxygens repeated. 1 is in the H2O and 2 are in the carbon dioxide. So like that we can observe. So hydrogens only at one place, they are 2. Chlorines only at one place, 1. Sodiums only at one place, 1. Carbons only at one place, 1. Oxygens at 2 places, 1 plus 2. Right? 3. Now look at them. They are giving you the same count on LHS side and RHS side. So in the table, we got different values. For what? For what? Sodium and hydrogen. So here count of sodium and hydrogens are changed. So that given equation is balanced one or unbalanced one? Unbalanced. Then what to do? We have to start selecting the largest compound formula. Right? Then largest compound formula is Na2CO3. Right? But here, if you go for Na2CO3, it gives you difficult. It gives you difficult. Why? Here, first you will go for oxygen. Okay, oxygen. Okay, here oxygen count 3, same is there. Need not to select that one. Right? So that's why I'm going for second largest compound is H2O. Right? H2O. Hydrogen count is 2 here. But LHS side, only 1 is there. So to make it 2, I'm using multiplier, right? Here it's a subscript. In HCl, it's a subscript is 1, right? Chlorine subscript also 1. Then I need to multiply this by 2. So that I am writing as 2 coefficient before the formula unit, not anywhere. Before the formula unit. So before HCl, I will write 2. So drop the equation, put the coefficient 2 as before HCl here. Okay. Then here, any change in the count of chlorine? Yes, changed. Here chlorine previously 1, but now 2 into 1, it is given 2. Where on LHS side? LHS side, it is changed as 2. Then what about RHS side? Only 1 is there. I need 2 also here. So coefficient using 2. Where? Before NaCl, because Cl is present in NaCl. So I will write the coefficient before NaCl. Right? 2 as coefficient. So written. Now count of sodium is changed. Count of sodium is also changed. So I got 2 on RHS side. Okay, there. Also same on RHS side. Sorry, LHS side. So now your equation is balanced. Let us verify that equation is balanced or not. Let us verify. Check your equation. So again, I am writing the count in the table. Hydrogens on LHS side 2, chlorines on LHS side 2, sodiums 2, carbon 1, oxygens 3. Then RHS side, just wipe out and write hydrogens 2 there, oxygens, chlorines 2 there in NaCl. Next sodiums 2 in NaCl. Next carbons 1 in carbon dioxide. Oxygens totally 3. 1 is in H2O and 2 are in carbon dioxide. So this is balancing of equations stepwise. If the long question asked to balance, right, like this, immediately give me your response. Time exhaust. Are you clear, everyone? Just give me your reply fast. Time completed.
Yes, sir. Thank you.
Yes. So Harshit, how do you feel? Your first class?
Sir, good.
Okay, thank you. Tomorrow we'll meet at same time.